Now, let's solve the Laplace transform of 4, the Laplace transform of 1/2, and the Laplace transform of -3. Now, it's important for us to always remember the equivalent expression for the Laplace transform of 1. We have that in the previous video. We're able to discuss the Laplace transform of 1 being 1 over s, and this was actually taken from this general formula. The Laplace transform of f of t, any function of t, is equal to the integral of e to the power of -st f of t dt 0 to infinity. Okay, so these were all the considerations that will allow us to approach to this value. So with this, we already have the general form or the form of this. Now we're going to look at what will happen if we're going to solve for the Laplace transform of 4. Okay, so using this formula, it should actually be like this. You have the integral from 0 to infinity of e to the power of -st, and we have here 4, and you will have, that's your Fourier function, and then dt. Okay, we will not be using this anymore, but I'm just discussing this so that we could apply the general form later, or probably come up with a general form later. So with this, actually being a constant, you can always move that out. Okay, so you will have here 4 times the integral of from 0 to infinity of e to the power of -st dt. This is actually the expression equivalent to Laplace transform of 1. Because when you substitute 1 here to dt in your formula, e to the power of -st, it's just actually the integral of 0 to infinity of e to the power of -st dt. And this is actually equal to, as mentioned, 1 over s. So with that in mind, we don't need to solve for this anymore. Simply substitute the equivalent expression of 1 over s. In short, the Laplace transform of 4 is just equal to 4 over s. Okay? So it's like that. Now, looking into the Laplace transform of -3, let's have -3 first before 1/2. Okay? So the Laplace transform of -3 will actually follow this idea, 0 to infinity that's e, sorry, my bad, e to the power of -st, then you have your -3 dt. As mentioned, you can always move the constant outside, e to the power of -st dt. And again, this is just equal to 1 over s. So you will have here the Laplace transform of Laplace transform of -3 is just equal to -3 times 1 over s, or equal to -3s. Okay, we are seeing now as a pattern. Okay, because when you look at this to the general Laplace transform of any constant, let's say c. Okay, any constant. Look at what happened to the Laplace transform of 1 being equal to 1 over s. The Laplace transform of, this is the Laplace transform of 4 being 4 over s, and the Laplace transform of -3 being -3 over s, which are actually the product of the constant here times 1 over s. So basically this is just equal to c, whatever that c is, times 1 over s. So the general form for the Laplace transform of any constant c is just c over s. Okay, so it's just c over s. This is general form. It's not part here, but we are not generalizing. Looking into that, since this is the next item, so let's not look into this anymore. Simply, again, it's just c over s. So your c is 1/2 over s. Using the laws of, or what do you mean, properties for fractions, so you have here 1/2 times 1 over s. So you will have here 1 over 2s as the Laplace transform of positive 1/2. So this is now the idea taken from this previous video discussing the Laplace transform of 1, and these are the results for this video. Thank you very much for watching.